Hey, structural analysis friends. We're now going to do an influence line for a little bit more complicated structure. So again, I tried to bring a little model here. You have to bear with me. I usually use this model in class, and I have some students help me hold it, and I don't have that right now. So anyhow, so first we're going to look at the influence line for the reaction at A, which is this fixed end over here. And so what we're going to do is basically we're going to shift this up one, right? But I have to hold this in place, so something like that. So I'm going to shift this out one. And so what's the display state look like? See, this goes up one. Because this is a fixed end, it can't really move. And so it has to stay one or straight all the way across there. Then it starts dropping down. It passes through zero at this support, drops down, and then drops up. And then we can plot the values based off of that. All right, so now we just want to plot that display structure as we saw it happen. So again, I'll come into point A, and I'm going to release the reaction. I'm going to shift it up a value of 1. So I always like to draw in what my structure looks like, where it's locked in. You can think at the roller supports, it has to be locked in at 0. I shift that up 1. Again, because of that fixed connection, it can't bend along that segment. And so we have basically a straight line heading all the way out. And then once we get to the hinge, it starts to bend. It passes through 0 at the roller. It then would have to remain a straight segment all the way to point D. And again, we're looking at rigid body rotation here. We can use similar triangles to solve the values. All right, now we're going to look at the influence line for the moment at point F here, which is somewhere over here. So you have to imagine we put a hinge in right here, and then we're going to bend this down. So it's going to... Now I can't, on this side, because this is the fixed end, I can't really bend this by putting a rotation. So all that rotation is going to happen on just this side. And so that's going to rotate down. And then again, this passes through 0. And so we end up with a display shape that looks something like that, where this rotates down. 1 times 10 will give us a negative 10. If this is negative 10, this is positive 10. This is 0, 0. All right. I hope that makes sense. All right, so now we're going to come into point F, and we're going to replace that with a hinge. So I'm going to draw my structure, but also with a hinge at point F. I'm going to apply that unit rotation at point F. So remember, we put that in the positive direction. And then that total, that theta total, has to be 1. And so I see on the left-hand segment from point A to F, I can't, rotate that without bending that segment. So therefore, there would be no moment, no value on that segment for the moment F when that point load is over there. And if you think about this with the cantilever, whenever that one kip load is between A and F, basically the fixed end support at A is doing all the work. If I then look at F, and on the right hand side I see that it can rotate down to the hinge, I draw in the display shape. Again, it's locked in at 0 at the supports. I can figure out what the value should be. Again, that rotation is 1. 1 times 10 feet gives me a negative 10 at the bottom. Similar triangles, positive 10 at the top. All right, one more time here. We're going to look at the shear at point F. So you have to imagine, like, if I clipped this or I broke it and I went... Psh, and so again, I'm going to apply that positive direction. Again, because this is a fixed end, I really can't move it on that side. And so it's on the right-hand side that it's going to shift. Now, again, positive shear is going to be down on this side and then up on this side. So since this can't move, this is just going to go shift up. So it's going to shift straight up. And then again, when it shifts up, that puts us at a value of 1. So that'll put us at a value of negative 1 over here, and then 0 at the 2 supports. All right. I hope that also made sense. It's been a pleasure. Hopefully these models helped you a little bit. We're going to finish up plotting that shear at point D, and then we'll get on to looking at more complex structures. All right, so again, I'm going to, for the influence line, for the shear at point F, I'm going to draw in sort of my whole beam structure, except at point F, I'm going to put in my break. And so at that break, I want to apply a shift in the positive shear direction according to my sign convention. So that's going to be down on the left-hand side, up on the right. Now, because from A to F, it has to remain a straight line. And at point A, we have that fixed condition with a slope of 0. So I really can't shift that down without causing bending in segment AF. And so the left side has to remain straight and it cannot deflect. And so then what happens is on the right hand side where I have the shift, all that total deflection is going to be all concentrated on the right hand side. So compared to the last example where it was shared, that that total one was shared left and right. This time it's not shared because it's not possible on segment AF. So it's all on the right. I can use similar triangles to solve the rest of the values.